All right, in this video, we'll review use substitution and integration by parts, and we'll practice figuring out when you should use which of these strategies and when the other. So as a review, use substitution is often used in a problem if part of the thing is close to the derivative of another part. So here, 3 plus x squared has the derivative 2x, which is very similar to this x, just off by a constant, which is okay. So I'm going to say u is the inside 3 plus x squared, and that would mean du is 2x dx. So I could rewrite this problem as an integral of, let's see, I'll have a cosine of u, and then the x times dx is this. That's equal to 1/2 du. Okay, antiderivative of cosine is sine, so I'll have my 1/2, and then I'll go from u back to x, 3 plus x squared plus c. And we can check that, because if you differentiate this expression, you'd use the chain rule and get back here. Okay. On the other hand, we have integration by parts, which is useful for problems like this. Always has to be two things multiplied together. We name one of those things u, and the other we name v prime. And in this case, I'm going to say u should be the natural log of x, because when we differentiate that, it's going to become simpler. There won't be a log anymore. And that means v prime has to be x cubed. So v would be 1/4 x to the 4th power, which is, so here the v is sort of worse, more complicated than the v prime, but that's okay because u prime is much nicer than u. So that's sort of an acceptable trade. So this integral we then write as u times v, so 1/4 x to the 4th natural log x, and then minus integral of vu prime, so that would be 1/4 x to the 3rd power, and that's now an easy integral. Okay, so those are two good strategies for integrals. How do you decide which one to do? In this example, I would say you should do substitution with u equals x squared plus 2, because the derivative of this is like the x. In this situation, there's again a natural log. It's very tempting to use integration by parts with that u, and this is v prime, because that differentiation will make the derivative of the log into 1 over 4x times 4. So that'll be much nicer. Here I would say, top looks like derivative of the bottom. I would let u equals 2x cubed plus 1 and do a substitution. Here u equals x squared should work as a substitution, not an integration by parts. And here, this is an interesting one. This is again a substitution, u equals x plus 1. And you can solve that for x, get x equals u minus 1, so that this becomes integral, and du is just equal to dx. So we'll have square root of u, and then out front a u minus 1 squared and a du. So that you can break into, you'd have a u squared minus 2u plus 1 all times u to the 1/2 power. And you could rewrite that as u to the 2.5 minus 2u to the 1.5 plus u to the 0.5, and then solve from there.